Right, we know how to simplify radicals. Now we're going to simplify radicals that leave us with radicals in the denominator. So our first example is the square root of 0.125. Now we've learned how to take the square root of decimal numbers before when they were perfect squares. And so we're going to use some of those same techniques here. One of the ways that we can take this square root is by writing the 0.125 as 125 times 10 to the negative 3. Now this is one way we can rewrite this number to take the square root. I'm not going to go this route in this problem this time because there are some other ways that are better. So I can write the square root of 0.125 as 125 over 1,000 because that's really what it is. It's 125 thousandths. So it is a fraction. And I'm going to work with it this way and show you that we can either simplify this the way it is or we can reduce it down and then work with it. Now if I reduce this down, I know that 25 will go into both of those. 25 times 5 is 125. So I can reduce the 125. I can divide it by 25 and get 5, and I can divide 1,000 by 25. Now, 25 goes into 100 4 times, but I have 10 hundreds down here, so that's 40. So this reduces to 5 over 40, which in turn reduces to 1 over 8. So this whole fraction here can reduce to 1 over 8 before I ever start working with the radical sign. Now, some of you may have recognized 0.125 as being 1/8, and then you wouldn't have to go through this process. All right, so we have the fraction, the square root of 1 over 8. The square root of 1 over 8 is the square root of 1 over the square root of 8, which is 1 over the square root of 8. But the square root of 8, we already know, can be simplified to 2 square root of 2. In math, we always like to give our answers with positive exponents and no radicals in the denominator. It's just a standard practice. So I want to do what's called rationalizing the denominator to get rid of my square root. I'm not going to do it when I have the square root of 8 up here because it's not simplified. You always want to simplify your square roots first. So I'm going to rationalize the denominator once I've simplified it. And it's only the square root of 2 that is a problem. This 2 is not a problem. So I'm going to multiply the numerator and the denominator by the square root of 2. That will make this radical sign go away. And so what happens is, in the numerator, I get the square root of 2. But in the denominator, I get 2 times, and then square root of 2 times square root of 2 is another 2. So I get square root of 2 over 4. Or I can write that as 1/4 square root of 2. Either way you want to write it is just fine. All right, let's do a cube root, because you can also simplify cube roots and rationalize cube roots. So let's say we have 1 over the cube root of 12x squared y. Now, the first thing I want to do is try to simplify my cube root before I rationalize it. So in order to simplify this, I need to look at all of the factors involved in this radicand. All right, well, 12 can be written as 4 times 3. 4 is 2 times 2. So I've got 2 2's and a 3 that make 12. And then I have x squared and y. All right, in order to simplify cube root, I need 3 of whatever's under the radical sign in order to take it out. Well, I don't have 3 of any one of those factors. So I'm going to have to rationalize it as it is, which means I'm going to be multiplying by the cube root of something over the cube root of something. Since I'm rationalizing a cube root, I need a cube root to do that. Now, remember, I need 3 of everything in order to remove the radical. So I have 2 2's. So I'll need 1 2 under my radical sign here. But I have 1 3, so I'll need 2 3's under the radical sign. I have 2 x's, so I'll need 1 more x. and I have only one y, so I'll need 2 more y's. So you see, when I multiply these two cube roots, I should have 3 of everything, and that will make the cube root go away. So in the numerator, I'll have the cube root of, now, 2 times 3 squared. 3 squared is 9. 2 times 9 is 18. So I'll have the cube root of 18 xy squared. But in the denominator, I'll have the cube root of, and then I'll have 2 2's and 1 2 make 3 2's. So I'll have 3 2's. And then 1 3 and 2 3's make 3 3's. So I have 3 3's. I have 2 x's and 1 x, so that's 3 x's. And I have 1 y and 2 y's, so that's 3 y's. So you see, now I have 3 of everything. I can take the cube root. So I'll have the cube root of 18 x y squared in the numerator, but in the denominator I'll have 2 and then 3. So 2 times 3 is 6, and then x, and then y. And I have simplified and rationalized my fraction with a cube root. Now, let's see when we might use this simplifying, rationalizing skill. Let's suppose that we want to combine these radicals that look very different from each other. Okay, we want to combine the square root of 72, and so it's square root of 72 minus 3 times the square root of 28 plus 4 times the square root of 50. Well, all of those radicals are different, so the way it's written, I can't do anything with it. But I need to simplify my radicals and then see if I can do something with it. The square root of 72 is the square root of 9 times 8. Well, I can take the square root of 9, and in fact, this is the square root of 9 times, and 8 is 4 times 2. So you see, I can take the square root of 9 and 4. The square root of 9 is 3, the square root of 4 is 2. Remember that you're multiplying, so 3 times 2 is 6. So I've got 6, and then the square root of 2 is left. The square root of 28 is 4 times 7. All right, well, the square root of 4 is 2, so I can rewrite this as 2 square root of 7. But remember, there's already a 3 outside, so that 2 is multiplied by this 3. So I really have minus 6 square root of 7. And then, same thing over here with the 50. 50 can be written as 25 times 2. Well, I can take the square root of 25, it's 5. So I had 5 square roots of 2, but there was already a 4 sitting there. So 4 times 5 is 20. So I really have plus 20 square root of 2. Well, now I can see that I actually have what we call like terms. I have 2 terms that have a square root of 2 in them. So I can just combine them. Positive 6, positive 20 gives me positive 26 square root of 2 minus 6 square root of 7. And I have simplified my radical statement. Let's do this one more time. We're going to have 6 over the square root of 12 minus the square root of 12. Now be real careful that you don't suppose that you can reduce 6 and 12, because 12 is under the radical sign and 6 is not under the radical sign, so I can't do anything with those two. But before I start either getting common denominators or rationalizing the denominator that has a root in it, I need to simplify my roots. Always simplify first. Always simplify first. So when I simplify the square root of 12, the square root of 12 is 4 times 3. So I can take the square root of 4, that's 2. So it simplifies to 2 square root of 3. Well, I can cancel my 2 and my 6. So I have 3 over the square root of 3 minus 2 times the square root of 3. Now I can simplify my, I can rationalize my first fraction. And that would probably be better than getting a common denominator, although you could go that route. But I'm going to rationalize this denominator first. So 3 over the square root of 3. And I need to remove the radical from the denominator. So that's, I'm going to multiply that by the square root of 3 over the square root of 3. So what I have then when I do this is 3 times the square root of 3 over, and the square root of 3 times the square root of 3, the radicals go away because the numbers are the same, so I just get 3. Well, those 3's cancel, so I just end up with the square root of 3. 3 over the square root of 3 simplified to the square root of 3. So I have the square root of 3, and then this one is minus 2 square root of 3. And square root of 3 minus 2 square root of 3 is negative square root of 3. And this simplifies to negative square root of 3. Like I said, if you want to get common denominators here, you should end up in the same place, but I think you're going to do a little more work to get there.